everyone. I am Renalyn Sidagnot, a Bsed math student of Negros Oriental State University, Shatun campus. So I will be reporting my assigned topic, which is Mathematics and Technology, the Role of Computers. Changes in Mathematics, Teaching and Learning. So according to Van de Walle, 1998, there are three ways technology in changing the nature of mathematics education. So the first is that some mathematics skills have decreased in importance. Time taken to perform tedious paper and pencil computations, such as long division or construction, such as graphical representations, and can be put to better use in more reasoning and interpretation-oriented endeavors. This approach, mirror-way technology, is used in everyday life. Second, the pedagogical idea that mathematics can be taught more effectively using computers. For example, visual and contextual representations that might not otherwise be available can be included. And teachers can use computer-based simulations to provide students with opportunities to work on problem situations that are difficult to experience without technology. Third, some mathematics topics and skills are more accessible or can receive greater emphasis. Data analysis is a prime example. The internet provides access to a plethora of information that, combined with data analysis tools and computer-generated graphs and tables, allows children to gather, represent, analyze, and interpret data at earlier ages and in expanded ways. Adults also have the opportunity to gain insight into new mathematical methods. A discussion recently took place in a mathematics educator list in which one participant shared a new technique for simplifying a radical under a radical, which he had just learned while using the algebra software Maple by Waterloo Maple. Motivated to investigate, he learned that the method had been around for centuries but is no longer taught in school. This led him and a friend to explore how the method worked. These changes impact mathematics content and curriculum. Instructional methodologies, including assessment, learning styles, and the nature of mathematical thinking and understanding. The National Council of Teachers and Mathematics, or NCTM 1998 content, when a curriculum is implemented, time and emphasis must be given to the use of technology to teach mathematics concepts, skills, and applications in the ways they encounter in an age of ever-increasing access to more powerful technology. Changes in favor of greater use of computers in mathematics education align nicely with other methodological emphasis presently espoused by experts in the field, most notably student responsibility for their own learning. Students become more autonomous while teacher more facilitative, and learning more authentic during carefully designed, computer-based projects. This student-centered environment also lends itself, contrary to popular belief about computer use, to collaborative group work. Students can pursue mathematics-oriented goals in JEDs and the computer, or they work independently and then share the results of their own work with other students. Finally, technology can naturally support interdisciplinary access to global data and communicators. It is important to note that the classroom teacher's philosophy of mathematics education and its implementation ultimately shapes classroom learning. Appropriate use as the technology in a mathematics classroom. Computer programs may be used for work with various mathematics concepts, including formulas, constructions, and proofs. Computers can also be used for accessing information and communicating with others mathematically. Whatever the uses of computers in mathematics, the focus should be on higher order thinking with an emphasis emphasis on inquiry, reasoning, and engagement in worthwhile mathematical tasks. Algebra instruction is one area that has been particularly transformed by use of computer algebra system or CAS, such as derived from Texas Instrument, Maple or Waterloo Maple, MathCAD or MathSoft, and Mathematica or Wolfram Research. Students explore mathematical patterns and relationships while the computer performs most of the symbol manipulations and graphical representations. Algebraic thinking is not limited to them to the middle grades above. Elementary students may also explore algebra concepts such as functions through age-appropriate software. Used properly, technology fosters rather than replaces mathematical understanding. Technology should be used as a medium that facilitates powerful mathematics learning rather than as an object of instruction in and on itself. It is a mechanism for accessing and processing information, modeling and exploring mathematics, and conducting mathematical investigations. In keeping with its role as a tool, teachers need to help students learn to decide when and how to use technology. Using computers, mainly for lower level applications such as computations or for demonstration, accompanied by exploration and reasoning severely undercuts their potential to expand and challenge student thinking and may in fact limit it. Computers hold little advantage over their non-electronic counterparts when they are used as the posers of problem and possessors of all answers to those problems. Higher levels of thinking are attained when students pose what if questions before the test ideas, such changing inputted information on a spreadsheet, like for example, a defined rule, or data in a graph. These types of analysis can develop more generalized thinking. The NCTM discusses appropriate use of computers in mathematics education. The effective use of technology in mathematics classroom depends on the teacher. As with any teaching tool, it can be used well or poorly. Teachers should use technology to enhance their students' learning opportunities by selecting or creating mathematical tasks that take advantage of what technology can do efficiently and while graphing, visualizing, and computing. So according to Cornell 1998 research, findings from work with 53 rural elementary students point to the importance of the classroom matching technology used to its underlying instructions philosophy. For example, a student-centered, inquiry-oriented classroom that uses technology primarily as a delivery system for prepackaged instruction represents a misalignment of instructional practice that can negatively impact students' learning. In short, using technology appropriately means emphasizing mathematical thinking in an environment with well integrated instructional approaches grounded in current mathematics education theory. Computer impact on mathematics learning. Computers have many features that can enhance student learning. Their multimedia capabilities lend a sensory component that may help reinforce concepts and appeal to a wider variety of learning styles. Graphical aspects to help students visualize 2 and 3-dimensional geometric figures and represent mathematical ideas such as the nature of arithmetic versus exponential growth. Furthermore, students can make conjectures and experiment with these graphical representations to see the results. In dynamic, interactive geometry programs, students may directly manipulate figures that remain intact as they change shape in continuous fashion, allowing students to see intermediate states. That figure shows how Pentagon created on Jupyter's Sketchpad, or K curriculum press was reshaped on an adjacent copied version by dragging vertex G. Dragging vertex G upward. Students can discover that the sum of the measures of the interior angle remain the same in such cases and explore differences between the diagonals of convex and concave polygons, or the latter having at least one diagonal that falls outside the polygon's region. Successful mathematicians often possess an ability to visualize mathematical ideas. Computers extend this ability to a much broader audience, allowing students opportunities to think with mathematical objects just as they might think with mechanical objects. This use of computers fits nicely with the current emphasis on use of manipulative materials in mathematics education. Testing, testing one's thinking and seeing the results, as noted, can be a powerful way to boost and stretch mathematical ideas. Students can generate a large set of instances from which they try to generalize, thus illustrating computing potentials for pursuing the abstract and the general. Kuku and Goldenberg in 1996 issued a caveat. However, the student can have too much confidence in computer results and move on too quickly after making assumptions from a diverse set of cases. This, of course, points to, points to the importance of the teacher's role in facilitating appropriate use of technology. Another important computer feature conductive is teaching and learning is the potential for individualization. Good computer programs allow students to work at their own pace and give useful immediate feedback on student performance. Numerous students have found that personalizing problems, inserting individual student name or other personal information into word problem has a positive effect on a student interest and achievement in solving the problems. Computers have been used in some of these studies to generate the personalized problems, demonstrating another way to individualize instruction. Certainly, computers possess another valuable features that give them instructional appeal. Two of note are their interactive capabilities and their motivational qualities. Numerous studies show that computer use conducted appropriately had a positive impact on students' achievement and other educational outcomes, like for example, attitudes in mathematics education. The Educational Testing Service, or ETS 1999, conducted a review of the results of the 1996 National Assessment of Educational Progress, which included national sample of 6,227 fourth graders and 7,146 eighth graders. The ETS reported that computer use improved both students' proficiency in mathematics and the learning environment of the school, as measured by reduced student and teacher absenteeism and increased teachers' morale. However, these benefits were found to depend upon proper use of technology, which has a greater effects than frequency of use. In particular, the report states that teacher needs to focus computer use on applying higher order skills. Both this report and research conducted by Divanay 1996 indicated that using computers frequently and for lower level skills like for example drill and practice may be detrimental to students. The frequent use factor, the ETS hypothesis, might result from unproductive computer such as playing non-educational games. So that's all my report and will be continued by my group mates. Thank you.